Let's talk about Unit 3 Part 2. Part 2 مش كبيرة على فكرة. I split it in two parts عشان Part 2 is just about light waves and it includes pretty much almost all the diagrams, whether it's the reflection of light, the refraction of light, the dispersion of light, the lenses. فكل ده اللي هنتكلم عليه النهاردة. هنتكلم بس عن light waves. Starting with the reflection of light. طبعا you know the drill by now. عندنا الchecklist بتاع كامبريدج أصلا بتاع revision. So you need to read this, and after you're done revising, you check if you understand these things. Like, do you understand what normal, an angle of incidence, and angle of reflection means? Describe the formation of an image by a mirror. Talk about its characteristics. اللي بتشوفوه. Angle of incidence equals angle of reflection. Use simple constructions and measurements and calculations. هنشوف كده دلوقتي. We talked about reflection already المرة اللي فاتت. قلنا the reflection of light or refraction of any wave هي لما الويف تخبط surface و change direction وترجع تاني. تقول لي صح. Done. Easy. And it followed one very simple rule that the angle of incidence is equal to the angle of reflection. اللي هي ايه؟ angle between the incident ray and the normal ده angle of incidence is equal to the angle of reflection. اللي هي ما بين reflected ray والnormal. These two are always equal. فلو دي ب 50 degrees دي ب 50 degrees. تقول لي we know this. I'm just pointing out تاني that the angles have to be measured من الray للnormal. ليه بقول الكلمة دي كذا مرة؟ Because sometimes ممكن تيجي في مسألة تقول لي or like a question give me كده oh this angle is 60 اللي هي الانجل ما بين الميرور والray. I don't use this. ماليش دعوة بيها دي خالص. Actually ليه دعوة بيها حاجة واحدة. Since the normal, which is the perpendicular line to the mirror, is at 90 degrees, دي كلها ب 90. فلو دي ب 60 يبقى ال angle of incidence is actually 90 minus 60 اللي هي 30. خلاص؟ So how do you get the angle of incidence لو هو مديني الانجل ما بين الميرور والray؟ 90 minus this angle. وتبقى 30. And then the angle of incidence is 30, the angle of reflection is 30. Easy peasy Japanese. Done. طيب ده الانجل اوف انسيدنس والانجل اوف ريفلكشن انسيدنت راي والريفلكتد راي. بصراحه ريفلكشن مش صعبه. However, when you look at yourself in a mirror, what do you see? Yourself, صح؟ Whether you're smiling, you're frowning, مش فارقه. You see yourself. ليه اللي بيحصل بقى؟ اللي بيحصل ان the light from you hits the mirror. Like let's say for example you have a shoe on your foot, a red shoe. The light from your shoe hits the mirror, reflects to your eyes, and your eyes and brain acts all stupid and thinks in the light rays دي جاية from behind the mirror. It thinks that the light comes from behind the mirror. يعني extend the ray of light ده فيتهيأ له إن the red shoe is behind the mirror. عشان كده بنسمي الimage that you see in a mirror a virtual image, as in it is not real. It's in your head, it's in your brain, it's virtual. ولو فكرت فيها شوية you will go crazy, so don't think about it too much. Like what's real and what's not real, it's all a matter of perspective. بس ملناش دعوة بالفلسفي كده for a second, خلينا في الفيزيكس. So basically the image that you see in a mirror is defined as not real because the light rays aren't coming from the mirror, they're coming from you. They're just reflected off of the mirror, so your brain thinks that the image or the light is coming from behind the mirror. Yeah. What other properties are there to an image in a mirror? Property number one, this image is upright. يعني إيه؟ يعني واقف, مش upside down. Number two, it's the same size as the object. يعني if I am 2 meters tall, أكيد طبعا like everybody who knows me, أكيد في ناس في الروم هنا have met me in person. I am 2 meters tall. Please agree. خلاص I'm 2 meters tall. Okay. يبقى الإيمج بتاعتي هتبقى إيه؟ 2 meters tall مش 1.6 ها؟ لا 1.64 لو سمحت. So ده الهايت, it's the same size. واحنا في السيلبس بتاع الأو level we don't talk about curved mirrors, ملناش دعوة بيه. It's just straight or plane mirrors. Second, the distance between the mirror والobject هي the distance between the image and the mirror. So if I'm 1 meter away from the mirror, my image appears 1 meter behind the mirror. كل ما ارجع لورا اكتر the image برضو بترجع لورا اكتر. كل ما اقرب من الميرور the image بتقرب من الميرور. It moves closer. Okay. So all of these properties you're familiar with. However, finally بقى بنقول that the image in the mirror is laterally inverted. What do I mean by that? This means that the right وال left are reversed. اللي موجود على اليمين بيبقى على الشمال واللي على الشمال بيبقى على اليمين. So for example, if you have a t-shirt with the word physics and an arrow pointing to the right عليها, the reflection will have the word physics with the arrow to the left. And every single letter will be flipped. Yeah. That's what we mean by laterally inverted. تمام? It appears that way. Finally, and since this is a lesson about light waves, we're going to be drawing lots of ray diagrams. A ray diagram to find the location of an image in front of the mirror requires at least 2 light rays. So from your object, دايما هيديني object like a dot or a point, and the mirror is just a straight line labeled as mirror. Sometimes بيعملوا this dashed line behind the mirror to show you the back side of the mirror. But the line is the mirror. How many rays do we draw? Step 1, draw any 2 light rays. Any 2 light rays يخبطوا mirror at any points and draw the norm عند كل واحدة. Step 2, measure the angle of incidence دي وزيها angle of reflection and draw the reflected ray. So measure this angle of incidence, measure the angle of reflection قدها and draw the reflected ray. So we measure these, we measure these and we draw the reflections. The reflected rays will not meet ever. If they meet, you've done something wrong. They're not going to meet. Instead بقى نفس الray دي, like the same ray, sorry, the same ray that you've drawn كده, you will extend backwards. The same ray that you've drawn كده, you will extend backwards until these light rays do what? Intersect. That point of intersection is where the image will be. ولو انتوا راسمين صح, like if your diagrams are accurate, the image and the object will be in front of each other. قصاد بعض. The distance between the image and the mirror and the object and the mirror will be equal. تمام? That's how you draw the ray diagram for a reflected image, to find the image. Very good. Okay, cool. Look, if you didn't get it, you'll see how we apply this, not in the first question, in the second question, because we want to see where the image will appear. But let me spoil something really quick, Zahra. If this is the object that's emitting light, and here's the mirror, where is the image going to appear? Like without drawing the light rays, where is the image going to appear? Behind the mirror, not on the mirror. It appears as if it's behind the mirror. And your eyes know, your brain knows it's on the mirror, but it appears behind the mirror. ففين? Where exactly? Somewhere here, صح? It looks like it's like 1 meter, 2 meters behind the mirror. So what we're going to try to do is draw light rays to find the location of the image. Okay? Before I solve these questions, let me show you a method where we cheat a bit, just a little bit. الطريقة دي بحب أسميها الطريقة المصرية. For a reason, like the Egyptian method. Why do I call it the Egyptian method? عشان في مصر وانتوا عارفين طبعا بنحب نجيب من الآخر. So here's the shortcut to find the location of the image. you can start with step 4 and go in reverse. بمعنى, if this is the object, I already know فين الimage. Where's the image? Behind the mirror. The same distance behind the mirror. فنعمل ايه? We measure this distance. We measure the same distance behind the mirror in front of the object, and we mark our image. That's step 1, actually. So this is where the intersection of the extensions will be. Step 2 is to draw any two light rays بالextension بتاعتهم through the mirror. Step 4, draw light rays from the object to the extensions and draw a normal to pretend that you've measured the angles. That's how you draw a ray diagram to find the image. بس we cheat and we find the image first. Like we put the image down first, but I can nirسم light rays in reverse. I'll show you how to do this in an actual question بقى. That's the only question you need to use. خلاص? I just had to teach you the correct way عشان للأسف Cambridge needs you to know the correct way first. Did my mouse just stop working? I just changed the battery 2 days ago. Just a second. And yeah, next. Let's solve a couple of questions. Now, I'll be honest with you, reflection questions do not show up very often or very much at all. But so let's solve a couple of them first. This is from June 22. Figure 7.1 shows a plan view of a room. So this is a room from above. There's a plane mirror on one wall and a picture across the whole wall AB. So there's a picture of, put whatever it is that you want over here. Maybe it's a stick figure man. Smiling creepily كده. I don't know why, بس يلا. I'm not very creative today. A person is standing at a point X and is looking at the mirror. The person cannot see all of the picture on the wall AB reflected in the mirror. ليه بقى? Here's the thing. Depending on the size of the mirror, you can see a lot or a little bit of reflection, right? Like if I grab my phone and use the screen like a mirror, like if I use its screen, its reflective screen like a mirror, and I hold it so that I can look at the room behind me, can I see the whole room? Well, just as much as this small mirror will allow. الحجم اللي اقدر اشوفه قد ايه؟ على قد السكرين بس، على قد السكرين الصغيره دي بس، just as much. فايه الحل بقى؟ Or, I mean, why does that happen? I'm going to explain it, then I'll answer, even though my answer is going to be the explanation. The limits of the mirror هم the edges of the mirror, which means if there's a light ray that's going to reach you when you're at point X, it either hits this end of the mirror and reflects, or it hits this end of the mirror and reflects. That's the only thing that you can see. It's the only thing that you can see. Okay? And that's the limit of what you can see. So question. If you take a look at what I've drawn, shaded area دي كلها, I want the marker. shaded area دي كلها is what you can see reflected in the mirror. إن هو كل ده اللي هيوصل. دي اللايت ريز اللي وصلت شوية دول كده. So how much of AB can you see? يعني from the stick figure العنيف اللي أنا رسمته ده. limits بتاعتي هنا. That's as much. From B لحد هنا. That's all I can see. From A to this point, I can't see. فأنا بس technically هشوف إيه؟ The bottom half of the stick figure man. If it's on the wall. وهو نايم كده. طيب, I have a question before I actually answer the question بقى. What if you draw the light ray on the center? Yalla, I'll humor you. What if the light ray comes from X to the center? Where's the reflection? Oh. Yani you see this part of the room. You see this part of the room. Every single light ray that reaches you shows you a different part of the room. We don't have to draw every single reflection. خالص. Instead, what do we draw? هما اتنين بس. Like if you want to find out how much can you see total, يعني آخرك قد إيه for how much you can see, you draw two rays. One to the farthest edge of the mirror عشان تشوف آخرك إيه هنا. Like what's the farthest thing you can see. And one to the first edge of the mirror to see where you start seeing. Okay? So you draw a ray بالreflection بتاعتها from one edge of the mirror to the next. ده عشان أشوف what can I see. So in this room I will see this wall and this wall. ده اللي أنا هشوفه because هو ده كله اللي باين. Now let's read the question. There is a point P on the wall which is closest to point A that the person can see reflected on the mirror. On figure 7.1, draw a reflected ray and an incident ray to show the position of point P. So he wants the closest point to point A. فماليش دعوة ب I don't want this. So what will I do? هرسم ray from X until this end, the closest point to A is on the mirror, and draw its reflection. And mark this point. So what is this point called? He said this point P and label it P. So I'm just going to mark this point and call it P. فهمنا الكويستشن؟ فهمنا هو قصده ايه هنا؟ Reflection is not very common, but when it does show up, it's a doozy sometimes. طيب نكمل بقى. Excellent. طالما understood يبقى it's excellent. State two properties of the image formed by the mirror. ايه ده أخيرا سؤال سهل. Okay. What are the two properties? You can mention more than, like you know more than two, but you only need to mention two. It is virtual. It is the same size as the object, same distance. I'm just going to mention the first two that popped in my mind. Same distance from the mirror, same size of the object, same virtual. صح صح صح. Next. This is not a reflection question. This is from the spectrum from last time. So visible light is an electromagnetic wave. State the name of one region of the spectrum in which the waves have shorter wavelengths than visible light, so less than violet in terms of wavelength. So you have ultraviolet or X-rays or gamma rays. Longer wavelengths, you have the other side, infrared or microwaves or radio waves. Choose whatever you want. This is from last time. Nice. Next. Here's an actual reflection question with an object and a mirror, and he wants to see the image. A boy looks at the image of a clock in a plane mirror. Figure 5.1 shows the mirror, the clock, and the position of one of the boy's eyes. On figure 5.1, draw a ray of light. Draw one ray, see? A ray of light from the clock reflected to the boy's eyes. So just one ray. We're just going to draw. I'd rather draw it exactly in the middle, you know? And then to the boy's eyes. There we go. On figure 5.1, mark with an X the position of the image of the clock. He's even asking me to cheat. Where's the image? Had measured distance D, so I'm going to even use my own hands, just my fingers. Just gonna take this distance over here and put it over here. And he wants with an X, so here's an X. This is the position of the image. Okay. State whether the image formed by the mirror is virtual or real. Explain your answer. So, our answer is that it's going to be virtual. Why? Because, and this is the definition of a virtual image, it cannot be seen or formed on a screen. A virtual image, right? A virtual image cannot be seen on a screen. It cannot be formed on a screen, which means a real image can be seen on a screen. Before I continue, you don't understand the X? That's the image. Like, I called it X because he said, mark with an X the position of the image of the clock. If this is the clock, where is the image going to be? In. So, نفس الديستنس دي هي نفس الديستنس دي. In front of it على طول. تمام؟ امتى اقول ان image is magnified? Not in a mirror. Not in a mirror. Mirror ما بيعملش magnified images. Lenses will, بس not a mirror. Figure 5.2 shows the image of the clock seen by the boy. So this is the image. This is the image. The boy now looks directly at the clock. What does he see? احنا قلنا ايه؟ The image in a mirror is laterally inverted. يعني ايه؟ اليمين, the one stuff on the right is on the left, والشمال stuff on the left be on the right. يبقى يمين. So اللي على اليمين شمال, شمال يمين. Right is left, left is right. So what will he see? Yeah. We're going to draw this minute hand up here like itself على طول كده. But the hour hand, the thick hand, is over here. But we draw it just as short as he did. Small arrow will be on the left, which means it's كام 9 o'clock بالظبط كده. Very good. And now we're done with reflection. Anybody have any questions about reflection? Yes, على reflection. Excellent. Next. The refraction of light. And this involves a bunch of calculations. ركزوا معايا كويس. We have a bunch of things to calculate and a lot of different types of refraction. So, first, what do I mean by refraction? From last time, refraction is when a wave moves from one medium to another. So what happens? The speed can change. And if the speed changes, the wavelength will change. And if the ray hits the surface at an angle, it will bend. So just as a reminder, if this is a block of glass and you have a ray of light داخلة perpendicular to the block of glass, it will not bend. Can somebody tell me why it will not bend from last time? Why will this not bend from last time? Because it's on the normal, or it is perpendicular to the surface. Or the angle of incidence is 0. All of these are correct answers. طالما light ray, our ray, or the wave is perpendicular to the surface, it does not bend. It does slow down, but it does not bend. However, if light hits the surface at an angle, زي ما هنا في الرسمة it's 30 degrees, the light ray will not continue in a straight line كده. لا. Instead, it will bend closer to the normal. Mr. نرسم النورمال فين? This is important. دايما نرسمه النورمال perpendicular to the surface, يعني at 90 degrees to the surface, where the ray hits the surface. Draw the normal where the ray hits the surface. دايما. لو سمحتوا. and it's perpendicular to the surface. هيقرب. And then, what if the light ray is moving from glass to air? So هنا it was air to glass. هنا it is glass to air. So how will this bend? ده مش هيكمل على طول. Instead, it bends away from the normal. It will bend away from the normal. But here's the funny thing بقى. Since this is a parallel-sided block or a rectangular block, both sides are parallel, the incident ray and the emergent ray are also parallel. The incident ray and the emergent ray are parallel. اللي داخل واللي خارج parallel لبعض. They're both parallel to each other. Okay? بس كده. Now, there's another thing. Any light ray that hits a glass surface, like, glass, maybe it's water, it's a transparent surface. It's not a mirror, but it's a transparent surface. هيحصل إيه? Some of the light will reflect. It's not full reflection. It's not just pure reflection. Some of the light reflects. This is why, again, if I grab my phone, let me turn it off, and I point it towards you, انتوا هتشوفوها كده دلوقتي. هتشوفوا ايه؟ The screen is reflected. يعني انتوا شايفين الصورة. I'm sure like if you look close enough, you see the picture. It's not 100% reflected. It's kind of transparent شوية. That's because some of the light gets reflected off of the glass screen اللي عندنا. Some light will always reflect. Some. شوية. الحمد لله. Next. This was refraction, but wait, there's more. Like we said بقى, a light that travels in air is faster than light that travels in glass. For glass is more dense, that's why it bends closer to the normal. The speed of light in air is 3 times 10 power 8 meters per second. We discussed that last time. But the speed of light in glass is less than the speed of light in air, and it's usually around 2 times 10 power 8 meters per second. The ratio between the speed of light in air هنسميها C قصدي مثلا, for example, and the speed of light in the glass, let's call it V, is called the refractive index. What is the refractive index? It's a ratio of the speeds of a wave in two different mediums. هي ratio بتاعت the speed of light in air over the speed of light in glass. Or in that medium, حط whatever medium it is. The symbol for the index is n. عشان دي هنحسبها بعد كده. We're going to use to calculate. ف n is equal to A. Speed of light in air على speed of light in the medium, in glass, in this example. It is also the same ratio as the angles بتاعت الانسيدنت والangle of refraction. دي اسمها angle of incidence. This is called the angle of refraction. The ratio between these two angles, أو مش exactly, between sine ال two angles, هي اسمها الايه؟ refractive index, n. How do we calculate the refractive index دي؟ بنقول n equals speed of light in air على speed of light in the medium. So in this example, it's n equals 3 times 10 power 8 over 2 times 10 power 8. هيطلع لي 1.5. Since it's speed over speed, يعني meters per second على meters per second, they cancel out, there's no unit. خلاص? N does not have a unit. Why? Because the two values cancel out in the ratio. The two units قصدي cancel out in the ratio. طيب قبل ما اشرح حتة sign للانجل دي, I want to point something out. What does 1.5 even mean كvalue؟ يعني لما اقول لكم n is 1.5, what does it mean؟ أكيد ليها معنى. It's not just a random number. It's physics. Come on. We don't have random numbers. unless it's quantum physics. دي حاجة تانية. N is 1.5. معناها it means that the speed of light in air is 1.5 times faster than the speed of light in the medium in glass. تاني, the speed of light in air is 1.5 times faster than the speed of light in glass. أسرع من اللي في الجلاس مرة ونص. That's literally what N means. Okay? فطبعا what if I tell you that you have another material with an index of 2 مثلا? What does that mean? It means that the speed of light in air is 2 times faster than the speed of light in the medium. Okay? بس قبل ما أكمل مرة كمان بقى. The speed of light in air does not change. فبasically دي معناها إيه؟ إن كل ما ال n تزيد, the higher the value of n, the slower the wave is in the medium. The speed of light in air does not change, ما بتتغيرش. كل اللي بيتغير هو اللي جوه الجلاس أو البلاستيك أو الواتر, whatever this medium is going to be. اتفقنا؟ طيب. Now, n is also sine. You all know what sine, cosine, and tan are. So it's sine theta air over sine theta the medium. Or sine the angle of incidence over sine the angle of refraction. Now, a lot of textbooks and teachers and everyone else, almost everyone else, likes to write sine I over sine R. And that's literally, by the way, what the Cambridge revision sheet says. Like the syllabus says, n equals sine I على R. I have one issue with this formula. This formula assumes that you understand that this is for light traveling from air to glass or air to water مثلا. يعني اللي فوق sine I is always from air, in air. هي الانجل الكبيرة divided by in glass. هي الانجل الصغيرة. That doesn't work if the light is traveling from glass to air. هنا ال I is 20 because that's the incident. ده اللي بيخبط. هنا ال R is 30. But that will give you a wrong answer of n. It won't be 1.5. هتبقى 0.667. So I prefer to say air over glass وخلاص. Now, you could say, hey, Mr. if it's moving from glass to air, it's sine R over sine I, because I is صغيرة والR كبيرة. Don't bother. لازم الانجل اللي فوق is always the one in air, the big angle. Less dense medium is always on top في الفانكشن في الايكويشن دي. And the more dense medium is always at the bottom. اتفقنا؟ عشان كده بقول sine air على sine glass so that you don't mix it up. وتقول is it more or less? Air فوق, glass تحت. Always. Am I clear? Very good. طب هنشوف questions where we calculate the index or use the index to calculate something else. طب كده خلصنا refraction in a parallel-sided block, meaning a rectangular block. Are there other types of blocks? أكيد طبعا. The medium isn't always glass. Sometimes you'll say plastic. Sometimes you will say water. But it doesn't matter. Whatever that medium is always at the bottom. Air is always at the top. Okay? Next بقى. What if you have a semicircular glass block? Now, this shows us a couple of cool features. And you can already see what I'm going to talk about. هتشوف أنا بتكلم عن إيه. But let's start with the first one. First, this light ray hits the surface, this curved surface, and does not bend. دي معناها إيه? What does this mean? يعني إيه إن this does not bend? يعني إيه this does not bend? يعني this ray is perpendicular to the surface. It's along the normal. The angle of incidence is 0. It's at 90 degrees to the surface. So it does not refract. It does not bend. There's no change in direction. اتفقنا؟ Any ray that hits that curved surface and doesn't bend معناها it's at 90 degrees. Done. اللي بعده بقى. When it's moving بقى from glass to air, as we agreed before, it will bend away from the normal. It will bend away from the normal. And that's okay. If you keep increasing this angle of incidence, هيزيد, the angle of refraction will also increase. هتبعد until eventually the light ray بيبعد عن النورمال so much it touches the glass surface. هنا بنقول that the angle of refraction, which is the angle ما بين النورمال والrefracted ray, R, is 90 degrees. The angle inside the glass, which is the angle of incidence, اللي بتخلي دي 90 is called the critical angle. And it's usually around 42 degrees. It changes from one material to another, a little bit less, a little bit more, but it's around 42. لما نيجي نحل مسائل ولو ال questions بتاعتنا ال n ب 1.5 ال critical angle هتبقى 42. So نكمل بقى تاني. ف critical angle بحوالي ايه؟ 42. If the angle of incidence is equal to critical, يعني الانجل بتاعتي دي 42، قشطة اللايت راي هتطلع لمسة glass surface. No big deal. If the light ray is less than 42, if this is 30, بيحصل refraction, just regular refraction, what we're used to. بس لو you know, you don't have to memorize 42. It's just هنشوف دلوقتي when we calculate the critical angle هتطلع بكام. If the index is 1.5 هتطلع لي 42. It's related to the material. فلو الانdex مختلف, like if it's not 1.5, what if this is a material with an index of 1.8? هل هتطلع ال critical 42? Like will it refract at 90 at 42 degrees inside the glass? لا. هنشوف بكام بعد شوية, okay? Good. Now, this is about the fun bit. If the angle of incidence of 42 causes it to touch the glass surface, يعني تبقى critical angle جوه و90 برا, what happens if you increase the angle even more? يعني زودتها أكتر من 42. I mean, it can't leave the normal any more than that. يعني خلاص لمسة glass. So it goes back inside the glass. When the angle of incidence is more than critical, and let's say it's 50 degrees, 60 degrees, whatever this is, بتحصل حاجة اسمها total internal reflection. What does that mean? What is total internal reflection? It is the complete reflection of light in glass. يعني, or if light is moving from glass to air, it's the complete reflection of light inside the glass. إمتى? When the angle of incidence is more than critical. So keep in mind لو سمحتوا, whenever you solve a problem, and the light is traveling from glass to air, you have three scenarios. If the angle is less than critical, refraction. If the angle of incidence is equal to critical, refraction, but the light ray touches the surface, the angle is 90 degrees of refraction. If the angle of incidence is more than critical or greater than critical, بيحصل total internal reflection. 100% of the light gets reflected. Guys, how do we calculate the critical angle? Since it's such an important angle, there has to be a way to calculate it. There is. بنقول the equation is n equals 1 over sine c. N is equal to 1 over sine c. N is your index, and c is the critical angle. طب if I want the critical angle, مش ال n, هنقول sine c equals 1 over n. راح نطلع calculator. Let's assume 2 examples عشان خاطر أحمد بس. هحل my example which is 1.5 And then Ahmad's example, when we said, what if the n is 1.8? Like it's a different material. هل هتطلع 42؟ هنشوف. So first, هنقول 1 over, عشان I want C. هنقول 1 over n, 1 over 1.5, ونعمل shift sign. So we shift sign our answer. So shift sign 1 over 1.5 فيطلع لي 41.8. Can you forgive me if I rounded it up to 42؟ لو قلت لكم 42 is that okay؟ ممكن تسمحوا لي بدي؟ Thank you. طيب أحمد, what if C sorry, what is the value of C if n is 1.8؟ يلا shift sign عشان أشيل الساين من هنا is 1 over 1.8. يلا 1 over 1.8 33.7 يعني 34. شفتوا؟ The critical angle isn't always the same. It depends on the material, because the different materials have different indexes. The value of n مختلفة for every material. تمام؟ Okay. Now, total internal reflection has one very, very important application, which is what? An optic fiber. What's an optic fiber? An optic fiber is a wire made of glass. Usually it's a mixture of glass and plastics, but it's a very thin cable made of glass. When light or any kind of electromagnetic ray, like infrared or light, goes inside the glass, بيحصل لها total internal reflection. It just reflects. Why? Because the angle of incidence is greater than critical. يعني وبصراحة it's not one light ray. يعني don't think it's just one light ray يا Mr. Muhammad. لا. It's multiple light rays. It's like lots and lots of light rays. Some of them are less than critical. A lot of them are more than critical. So a lot of them will reflect internally. ولو فاكرين حتى last time we said, hey, why do we use visible light and infrared waves in optic fiber في communications? We had multiple answers for that, like because the glass is transparent to light and infrared waves. صح? And you can transfer high rates of information with lights and infrared waves. So remember the advantages from the previous lesson. So what do we use it for? Like we said before, communications, internet, telecom, broadband. Why? We use it to transfer information using light or infrared waves, because they reflect light inside the fiber as their angle of incidence is greater than critical. So they use total internal reflection. The other application is in medicine. We call this an endoscope. بالعربي, للي يعرف العربي, منظار. That thing, that cable that they put inside you in a surgery and go like, it goes inside. And then that endoscope, which we call a transducer, remember that word, emits light, goes inside your stomach, lights it up. The light reflects back through the fiber and to the detector outside. So it shows on a screen. And then you can see what's inside your body. You don't have to describe it in excruciating detail. What do we say? You put optic fibers or a optic cable inside your patient. The light goes through the fiber and reflects back out through the same fiber part to the detector outside or to the equipment outside. That's it. That's how you describe it. You don't need to explain any more. You're not a doctor here, all right? You're not a biomechanical engineer. Okay. Next. What if you have a ray of monochromatic light that passes through a prism? Not a rectangular block, not a semicircular block, a prism. Well, first we have to answer يعني إيه كلمة monochromatic? Mono means one. Chroma means color. So monochromatic means light of one color. But since every single color has a different frequency, And in physics, we like to be specific. We do not define monochromatic light as light that has one color. We define it as light that has one frequency. And that translates to color in physics language. Okay? So monochromatic light is light that has a single frequency. What if you have white light? تقول لي يا مستر I remember white light has 7 different colors. ايه ال7 colors بتوعنا؟ Red, orange, yellow, green, blue, indigo, and violet. روي جي بيف. روي جي بيف. When white light hits a prism, اللي بيحصل هنا حاجتين. 2 things happen here. Refraction occurs. Because remember, this is still light traveling from air to glass. It's still refraction. But since every single color, وتعالى نمسك الred والviolet بس, because these are the extremes. Every single color has a different frequency with different wavelength. كل color بيبقى له change in speed مختلف. Red has a very large wavelength. Violet has a very short wavelength. So when red goes into glass and it slows down, مش بتسلو down قوي. So it bends closer to the normal, بس مش قوي, just a little bit. Whereas violet has a short wavelength, so when it goes inside the glass, it slows down a lot. So it bends a lot. They do. So it bends a lot. This is exactly what happens to every single color. Since every single color has a slightly different wavelength, every single color is going to change its speed by a different amount. So it bends with a different amount. Violet bends the most because it slows down the most. The velocity decreases the most. Red slows down the least. It slows down برضو. Get me wrong, it slows down. But that's because it slows down the least. Another way of saying this is that violet has a very large refractive index, whereas red has a short or small, refractive index. بما إن index is the ratio of speeds, the more you slow down, the bigger the index. But violet has a higher index than red. قولوها بالطريقة اللي تريحكم. You want to mention index? If I ask you why does it bend, go ahead. If you want to mention wavelength and slowing down, go ahead. This entire behavior of the white light splitting because it bends with different amounts is called dispersion. This is called a dispersion. اسمها ايه؟ dispersion. تمام؟ Remember, red has the lowest frequency, highest wavelength, and it slows down the least. Violet has the highest frequency, shortest wavelength, and it slows down the most. So it bends the most. And now we're done with refraction. But now let's solve a few questions. Some easy ones and some particularly nasty ones. Like this one. Even though it's not very nasty in the end. بس يلا واحدة refraction سهلة. Figure 6.3 shows yellow light. This is from specimen 23. Yellow light passing through a prism. Mister, أنا مش فاكر spectrum. So what do I do? I'll write it down so I don't forget. Roy G. Biv. Okay, so now we have yellow. Blue light enters the prism along the same path as the yellow. So blue now enters the same prism, the same path, كل حاجة. Draw the path of the blue light as it enters and passes through and leaves the prism. So what do we do? Will it bend more or less? Blue is here, so it bends more. Just draw another ray below the yellow and a little bit below yellow. It should bend just a little bit more, or as much as you can possibly make it. طيب ما تعملوش الغلطة دي لو سمحتوا. Don't make this mistake. في ناس تروح رسمة كده صح. رسمة كده صح. رسمة كده بصراحة ابتديت تأفور because now it's 90 degrees. رسمة كده. Okay, you're stupid. The light does not bend so close to the point where it passes the normal. يعني ما بيعديش النورمال ويدخل بقى لورا. يعني طب ما تقول لي ما يرجع بقى. Like, that doesn't work. So please do not make this silly mistake, which is a bending it way too much. That doesn't work. Okay? Pen or pencil? سمحتوا? Diagrams are always in pencil. Okay? Your written answers and calculations and stuff, that's pen. That's fine. Diagrams should always be in pencil. Next, from March 23 بقى. Figure 5.1 shows a semicircular transparent black plastic block. A ray of light is incident normally, يعني at 90 degrees, on the curved surface of the block. The refractive index is 1.5. Calculate the critical angle. I know. N equals 1 over sine C. بس أنا عايز C. فنقول sine C equals 1 over N. يعني 1 over 1.5 when shift sign. So where's my calculator? We'll shift sign. We know what the answer is. هيطلع C 41.8. Because we solved this example earlier. Now, on figure 5.1, draw the path of the ray in the block and after it emerges from the block. Now, I think a little while ago حد سألني and I forgot the answer. Should you measure the angles with your protractor? Well, most of the time you don't need to. بس بقول لكم إيه? Here you should. Not because you are going to draw with the same angle والكلام ده كله, you will, but that's not the reason why I'm saying. The reason you should is because you need to make sure that this angle is more or less than critical. يعني in this question, the examiner literally said, hey, find the critical angle for me. Oh no, draw the ray when it hits the glass surface and I don't know what's going to happen. فلازم أقيس الانجل دي. Anyway, بالنظر كده, just by looking, I can tell it's definitely more than 45 degrees. Like it's more than the bisector بتاع 90 degrees there. So it's more than 41 or 42. What will happen to this ray of light here طالما الانجل كبيرة كده? Total internal reflection. Total internal reflection. So that's all you do. Draw it reflecting. عشان clearly just by looking, you can tell and it's more than critical. How can I tell? Oops, sorry. How can I tell? Do you see this? Like I'll teach you what I do. Do you see this? This is supposed to be 90, right? What's the bisector of 90 degrees? 45 degrees. Okay, just by looking, it's 45 degrees. But just by looking at this 90-degree angle here, مش الانجل دي definitely أكبر من دي. Just by looking, it's like a protractor. What you're looking at is a protractor. من غير measurements, مش الانجل دي أكبر من دي. يبقى it's more than 45 because half of 90 is 45. Since the critical angle is 42 واحنا more than 45, احنا more than 42, هيحصل internal reflection. من غير أي شك, no doubt about it. هيحصل internal reflection. You're welcome. يلا. June 23, paper 43. The critical angle of a glass in an optic fiber is 45 degrees. What is the refractive index? سؤال بس بالعكس. Now he wants n. So we're just going to say n equals 1 over sine C. 1 over sine 45. That's 1.4. 1. Yeah. Before I move on though, I want to point something out. لا عايز اشرح حاجة هنا قبل ما ندخل على السؤال اللي جاي اللي تقيل شوية. Number one, please make sure your calculator is set to degrees. يعني فوق في calculator, there's a D in the box up here. Like the D in the box up here. Okay? It has to be in degrees لو سمحتوا. And number two, هو ليه n equals 1 على sin c? Like, what's this about? Well, ده علشان if the angle inside the glass is critical, the angle in air is 90. And according to the rule, sine the angle in air, which is 90, over sine the angle in glass, which is critical, equals n. هي الانdex. According to your math, sine 90 is a 1. This rule أصلا هي sine 90 على sine c, بس we just change sine 90, substitute sine 90 with 1 and you're done. Next. Figure 5.1 shows an optical fiber made of glass. Draw carefully a ray of light undergoing total internal reflection. Let me show you what not to do الأول. لو سمحت ده ما تعملوش كده. Please don't do this. Salam. You feel like reflection and you start shoulder. Reflection and you start drawing tons and tons of reflections. Do not do that. This is completely stupid and wrong because the angles here are all less than critical. It doesn't work. Instead, what do? Draw a ray that goes in and hits the surface at a very large angle من بعيد كده. Once. And draw it reflecting with a very large angle. At most, you should have 1 or 2 reflections جوه الجلاس. That's it. جوه الفايبر. مش محتاج أكتر من كده. Just draw 1 reflection with a very large angle. بس. That's all you need to do. Next. June 23, paper 1. سؤال جميل قوي على refraction. Look at this. Look at this. It's like a full A, B, C, D and double I and I وكل حاجة. Figure 5.1 shows a block ABCD made of glass that has a refractive index of 1.5. The block has one curved side AB, 3 straight sides AD, DCU, CB. There are right angles at C and D. The curved side AB is 1/4 of a circumference of a circle with the center at P. And we only, this is not just any curve, this is a circle, a quarter circle. A ray of monochromatic light enters the block through the curved side AB and strikes sides BC at P. Some light emerges into the air and some light is reflected. What is meant by monochromatic? Light of a single frequency or one frequency. Explain why the ray of light does not change direction when it enters the block through side AB. طالما اللايت ray ما عملتش bending يبقى هي داخلة at A 90 degrees. As long as the light ray hasn't bent at all, doesn't bend, it's normal to the surface. فهنقول له كده because the light ray incident on AB is perpendicular to the surface, so it does not bend or refract. ممكن تقولوا لي because the light ray has an angle of incidence of 0, so the angle of refraction is 0 برضو. It doesn't bend. مفيش change in angle because there is no angle to change. Okay? Show that this critical angle C for this index of 1.5 is 42. يعني show me that the critical angle is 42. فنقول له إيه؟ Sine C equals 1 over n. Therefore, 1 over 1.5 يبقى C is equal to sine minus 1 1 over 1.5. Show means write down your working بقى كلها in detail. So we're going to write the details. هيطلع 41.8 which is equal to 42 degrees. All the steps please. All the steps please. نفس السؤال اللي عملناه قبل كده. Figure 5.1 shows that the angle between the ray of light and the AP is theta, where line AP is at right angles to the line BC. So here's AP and AP and it's perpendicular to the line, and theta is the angle. The angle theta increases to 45. What will happen? إيه ده mister? Yes, if this angle increases to 45 بقت هنا. هي مش 45 كده. More than critical. Critical is 42. ف 45 is more than 42. فهيحصل ايه؟ Total internal reflection. فهنقول total internal reflection occurs because it said state, that's the statement, and explain for explanation. Because the angle of incidence is greater than critical. Or 45 is more than the critical angle of 42. Yes. When theta equals 45, the reflected light ray strikes the side CD. So أنا هرجع وهكمل رسم لنفسي. So if this light ray that's at 45 reflects at 45 نفس الانجل, just give me a second, I'll check the angle. And it hits CD. Tell you what, just by looking بالحب كده, هل دي أكبر من critical? Like mathematically, just by looking, is this more than critical? Huh. I'll wait. Is this more than critical? I'll wait. Geometry, please. مش دي 45? مش دي 45? Isn't this 45? Then what's this? A reflection. So what's this? 45. لو دي 45 ودي النورمال على السيرفيس which is perpendicular هنا كمان, يبقى what's this? 45. But if this is 45, it's still more than critical. It will reflect again. ركزوا في الفاليوز ها. ركزوا في الفاليوز ها. ايوه وقعتكم في الفخ ده قبل كده. Like I was like oh بص ده بالحب وعدت المره دي مش بالحب خالص. مفيش حب. There's no love here. Examiner doesn't love you. The angle is 45. And he used a very easy number, but like this was on purpose. He used a very simple number. 45 does not change. It's 45, 45, 45, no problem whatsoever. So describe what happens when this reflected light strikes CD. Or you can say all the light reflects, because I'm bored of saying total internal A reflection. There you go. خدت بالكم من السؤال ده؟ I love it. I love it. طيب. يلا. Anyway. Next. يلا. Last bit بقى for today. Last bit في الشرح بقى before we solve questions again. The last object that bends light is a lens. Now, lenses, we're just going to finish this. Like, we're going to do this and finish it. We only need like 15 minutes or something to finish. Okay? It's just this. استحملني شوية. ده بصوا, just so you don't get too tired. It's just this, and a couple of questions. Now, what's a lens? A lens is just a sheet of glass that's not equally thick في الcross section بتاعها on the side. You have different types of lenses, and we're focusing on two types. Actually, we're mostly focused on one type, and we won't be focused on... I'm so sorry, I'm trying to hold back. It's a pun, and I hope somebody notices. We're going to be focusing on one type and not focus much on the other type. The type we'll focus on a lot is the convex lens, which does what بقى? A convex lens is a lens that's thick in the middle and thin at the top and bottom. When a light ray, and I'm going to only do this once, okay? When a light ray hits the surface of that lens and we draw a normal, it bends closer to the normal. And then when we draw another normal, it bends away from the normal, just like a prism. So if you do this with every single light ray that's parallel to each other that hits the lens, you will find that they all end up refracting and passing through a single point. والpoint دي ايه؟ اسمها الfocal point. We call this type of lens a convex or a converging lens. The word converge means towards each other, يعني بيقربوا لبعض. So the light rays, if they're parallel to each other, they will all bend and pass through what we call the focal point. We sometimes call this the principal focus. So what is this point? This is the point where parallel light rays will meet after they pass through a convex lens. Very good. But there is another type of lens that's the mirror opposite. It's called a diverging lens. كلمة diverging, the word diverging means away from each other. بيبعدوا عن بعض. And this is literally what this lens does. It takes the light rays وبتبعدهم عن بعض. Like it moves them away from each other. ده اللي بيعمله اللايت rays. But see, here's the thing about a diverging lens. When it bends the light so that it bends away from each other, it doesn't just bend randomly وخلاص. لا. The extensions بتاعت اللايت rays دي that bend all pass through the same point برضو. We call this the focal point. So even when they spread out or diverge, it's calculated. We design it to spread it out with a specific angle according to the focal point of the lens. تقول لي ماشي يا مستر, okay. Then what? What's the point? Lenses have lots of applications. One application is in cameras or مثلا in a projector, and it's used to produce an image. يعني بنحط lens in front of an object that emits light. Again, we put a lens in front of an object that emits light, something like a light bulb, and you end up seeing that image or the light from the light bulb as an image on a screen. So the light from the object passes through the lens and you end up seeing it on a screen. This is an image. How do we find out where the image is? Like, how do we find out where the image is? Well, we draw a ray diagram because, of course, it's physics. Come on, we have to draw. In order to find an image, we need 2 light rays. بس there are 3 that you can draw. So we're going to draw all 3. نشوف all 3 now. But before we start, here a few basics about the image first. First, we have a horizontal line. This is called the principal axis. The principal axis is just a horizontal line that passes through the center of the lens. Second, we need the lens. This is given. Third, we need the focal points. These are usually given. Or they give me the focal length, which is the distance between the focal point to lens. So like 2 centimeters. Here's 1 centimeter, 2 centimeters. And third, we need an object. The object is always an arrow. تاني, object is always an arrow. دايما بيبقى arrow واقف كده. The height of the arrow is very important. هو بيبقى راسمها accurately. What do we draw? Like I said, there are 3 rays that you can draw. Let's look at the first. The first ray is a ray that's horizontal first. A ray that's horizontal. وبيعدي على مين? It stops here في center line بتاع lens, and then it passes through F اللي هي focal point, and you draw the extension of this line. Like just keep drawing. That's their first ray. The second ray is a ray that comes from the top of the object برضو. It comes from here, from the top of this object برضو, and it passes through the center of the lens. That's النقطة اللي في النص دي. وتكمله على طول. It doesn't bend. Any light ray that passes through the center مش بتبان. كده جبنا الإيمج. Like if you haven't noticed, here is where the top of the image will be. فبنروح راسمين arrow from the axis to that point. في شوية ناس بتغلط وتروح مشاورالي بس على البوينت. I'm not pointing towards it. I'm not like drawing an arrow to indicate where that point is. لا. The arrow is your object. And your arrow is the image. فلازم ارسم image by drawing a line من الأكسس لحد النقطة. Then add an arrowhead to it. This is your image. طيب مستر انت قلت there are 3 rays. طب ايه ray number 3? Well زي ما انتوا شايفين. If you want to draw a third ray, also from the top of the object, you first pass through the first focal point. في دايما 2 focal points for a lens, because lenses are symmetrical, so they have 2 focal points. You pass through the first focal point until you reach the center بتاع lens. وبعد كده تطلع horizontal. You draw a horizontal line. If your drawings are accurate, and they must be very accurate, هنعدي كلنا على نفس الpoint. Everything will pass through the same point. No change, no difference. Now, images have properties. The image formed by a lens has properties. This image, for example, is real. مش virtual, it's real, because if you put a screen there, اللايت هتخبطها وهنشوف image. You're going to see an image on a screen if you put a screen there. Second, it's inverted. يعني ايه كلمة inverted؟ يعني upside down. This arrow points up. The image is now pointing down. This image is the same size as the object. This is 2 squares high. This is also 2 squares high. طيب. بس بقول لكم ايه بقى? What can change the properties of this image? One thing. Where the object is. We have 3 cases. Okay, we have 3 cases. Case number 1, if you move the object close to the lens, بس لسه ما وصلش للfocal point. It's very close to the lens, but it has not reached the focal point. If you draw your light rays زي ما رسمنا هنا, these light rays will intersect very far away. and the image is going to be real يعني can be seen on a screen, inverted because it's upside down, it's pointing down, and enlarged يعني كبير. That's how a projector works. The light bulb or screen بتاع projector is very close to the lens. So it creates an image that's very large, like when you watch a movie in the cinema. It's very large on a screen that's very far away. Second, if you move the object back farther away from the lens and you draw your light rays, they will intersect somewhere here. The image is going to be real برضو inverted, but it's going to be smaller in size. It's diminished. Diminished يعني smaller in size. I'll answer that question in a bit, Yarana, okay? It's smaller in size. It's called diminished. What do we use this for? A camera. Like any camera, even your phone's camera has a bunch of lenses here. ايه الفانكشن بتاع lens? It takes all of the light that's very far away and it focuses it on a small sensor جوه كده. So we need to be able to like shrink اللي احنا بنصوره ده لحاجة صغيرة عشان يفت على الفيلم أو السنسور بتاع الكاميرا. But I say this next one is the most important ray diagram. Very, 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 very important. ليه بقى? If you put the object between the focal point and the lens, anywhere here ما بين الفوكال point واللens, you will not get a real image. بصوا ليه؟ From the top of the object هرسم ray number 1 which goes to the center ويعدي على F. بعد كده هرسم ray number 2 which passes through the center of the lens, no bending will happen. The rays don't meet. زي الايه؟ Just like reflection. فبدل ما نرسم lines with intersect هن extend them backwards. نعملهم extension A backwards. And they will intersect backwards هنا. This produces an image. الإيمج الوحيدة اللي upright. They're all inverted except for the virtual image, which is upright. And it's enlarged. But it's virtual. ليه؟ إن دي مش actual light rays اللي عملت intersection. دي extensions اللي عملت intersection. And this is how a magnifying glass works. لما بنجيب magnifying glass بناخدها ونحطها very close to the text that I'm reading. فيبان التكست ايه؟ كبير. فيبان التكست كبير. Okay? Very good. آخر حاجة, and I want to tell you something بقى. This is new to the syllabus 2023. ماشي? This bit is new to the syllabus. How do we use lenses to correct vision? Well, in order to understand that, let's understand vision. The way your eyes work is that your eyes have a lens, and then over here you have your retina. When light rays go through your lens, the light rays focus and they create an image على retina. Now, Rana, you said, how about glasses? Is the image isn't inverted? Well, here's the thing. Your eyes already invert the light anyway. يعني لما بتوصل اللايت ريز للريتنا بتاعتي جوه هنا, they're inverted. And your brain turns it back up. Okay? بس the correct way for your eyes to focus light is to focus it على الريتنا, which is the part of your eyes that receives the light. فيها cones كده بتreceive اللايت وبتtransfer light rays دي لsignals لمخك وكل حاجة. But there are two types of people. People like me wear glasses because they are short-sighted. Short-sighted معناها بشوف القريب, I see what's close, but I do not see what's far away. And then people like my father who are long-sighted, meaning بيشوفوا بعيد but they can't see what's up close. يعني if they hold a sheet of paper in front of their eyes, they won't be able to read You go like, أنا مش شايف. I need my glasses. What's the problem? The problem with short-sighted people in their eyes over-focus the light. The light rays focus before the retina, ahead of the retina. فمش بيشوفوا كويس. أما الناس long sighted زي بابا, what happens? Their eyes don't focus the light well. But they don't focus on the retina, they focus behind the retina. Both are a problem. So what's the correction? For people who are short-sighted, we give them a diverging lens, which spreads the light out and then focuses it on the retina. Since you over-focus the light, we unfocus it شوية عشان ندي فرصة انها تفocus on your retina. So if you are short-sighted, we use a diverging lens to focus the light on the retina. خلاص? If you are long-sighted because your eyes cannot focus the light very well, we use a converging lens, which focuses the light, or what I like to say, pre-focuses the light before it hits your eyes, and then your eyes can take its sweet time focusing the light on your retina, no problem. This is exactly what you should say if I ask you to describe or how to correct this vision, this type of vision, or this defect in vision. Let's solve a couple of questions and we'll be done then. Yeah. This is from specimen 23. He's given me a lens, a principal axis, my focal points, and the object. And he says, on figure 6.1, draw two rays from the top of the object to locate the image, label the image. So just draw. Well, I'm going to draw a couple of rays. And before I start, guys, what do you think? تفتكروا الري دي الإيمج هتبقى real ولا virtual؟ يعني is it going to be real over here ولا virtual behind the object؟ باين إنها virtual. Yes, it's virtual. ليه؟ Because the object is between the focal point and the lens. And before I even start, the object is between the focal point and the lens. So if I draw, نرسم first ray that's horizontal, and then it passes through F. طبعا I know it's going to be virtual, so I'm going to extend the F backwards as far as I can go. Then the second ray that you'll draw will pass through the center of the lens, this point over here. Yes? And I'm going to mark the points اللي أنا عديت عليها, so you know in blue. First, دي عدت هنا, بعد كده هنا. Second, دي عدت هنا. That's it. And then I'll extend this ray with my ruler backwards بنفس الانجل بالظبط. عملوا ايه؟ Intersection right here. This is your image. Label it I. That was AI. طب double I بقى. The object is moved to the left along the principal axis. So he moved it to the left and oba, it's right before F1, like it's somewhere here before F1. Figure 6.1 is a diagram of the new arrangement. Underline 3 of the terms below that describe the image. So it's not a question about drawing. Like, I'm not going to draw. I'm going to draw this just so I can show you that his diagram is correct. Right? Show you that his diagram is correct. It's absolutely fine. There's no problem with this diagram. But he just wants you to underline the terms. What is this image? Is it diminished or enlarged? With my ruler or my fingers, I'll just check the height of O and the height of the image, and oh, the image is bigger. So enlarged. Inverted, yeah, inverted. Real ولا, oh yeah, it's real. So it's real, inverted, enlarged. That's it. Did I need to draw? No. Why did I do it? Because I can. That's okay. Next. And finally, just two questions about vision defects. One where you draw, and the other where you just explain the defect. First, figure 5.3 shows a simplified diagram of an eye with rays from a distant object and a path of the rays inside the eye of a person with short sight. On figure 5.4, draw an additional lens outside the eye to correct short-sightedness and show the path of the rays of light inside the eye. So what do I draw? I draw a diverging lens. It does not have to look pretty. It does not have to be accurate. I just draw a diverging lens. And draw light rays. زي ما هو رسم just like 2 or 3, I'll do the same. هرسم واحدة في النص كده, reaches your retina. One here that just spreads a bit. You don't even have to draw the spreading. The important thing is that they meet at the retina. This is the important thing. So one mark for this and one mark for this. For the light rays meeting exactly at the retina. Next, state the name of the defect of vision that can be corrected by a converging lens. The lens that focuses the light for you, not unfocuses, زي short-sightedness. This is called long-sightedness. To be long-sighted, not short-sighted. Describe how a converging lens corrects the defect in eye. You may find it helpful to sketch a ray diagram. I'll show you what to sketch, but let me explain it first. Like I'm going to describe, because I don't have to draw, but then I'll show you how to sketch. So here's what we do. كل اللي هنقوله إيه? Without the lens, the light rays focus behind the retina. The converging lens focuses the light at or on the retina. That's all you need to say. هيحصل إيه? Without the retina, the lens, it's not going to meet on the retina, it meets behind. هيحصل إيه with the lens? What happens with the lens? The light rays will meet on the retina. هيحصل إيه without the lens? The light rays meet behind the retina. And if you want to draw, I would draw 2 eyeballs. I wouldn't draw 1. I would draw 2 of them. I would draw one very easy thing here. I would say, hey, look at this. The light rays meet here without the retina. And then, why do I keep saying retina? Without your retina, you see nothing without the lens. And then you draw another one, very simple, but you draw the lens, then draw the light rays meeting at the retina, and you just say with the lens. That's what you should do. It doesn't have to be pretty. It just has to be labeled and understood. And we are finito.